Okay, and we are live here from Millbury High School doing quadratic word problems 2. So that's the name of the game today. And we have an object that is thrust directly down from a height of 192 feet at a velocity downward of 64 feet per second. I want to remind you of the following equation. Please write this right below the problem. H is equal to negative 16 t squared plus vt plus s. That is the equation that will always model how objects move in motion, okay, with gravity. So we're going to come down here and we're going to start working on this problem for a second. But there's a couple things we need before we can get there. We probably want to identify the following: the starting point, the final height, and the velocity that it was thrown up with. So can somebody, why don't we start with green? That's where you start. Green means go. What is our starting height of this object? Take a moment and think about that. 192. So if you look at this problem at home or here in class, you're noticing that the starting height is 192 feet, right? Because that's where it was starting. A height of 192 feet. Now we need to figure out what the velocity was of this object. And remember, velocity matters, direction matters, okay? It matters if we get on the Mass Pike and head east or we head west. So we want to think about what the velocity of this object is. So think for just a moment about what that might be. Okay, so I've heard a couple of different ways of thinking of this. I've heard definitely 64, so everybody seems to understand that it's 64. But the key here is that it's a downward velocity, and downward means negative. So it is in fact negative 64 for our velocity. Don't miss that. That's important. If it's thrown up, it's a positive velocity. If it's thrown down, it's a negative velocity. The final resting place, where does this object going to be in the end? Where's it going to fall to? That's the question. Joe? 0, the height, the final height, h, the final height is going to be 0. So h is going to equal 0 because it's going to hit the ground. So the height is 0 there. And that's the cool thing about these problems is now we can ignore all of the words. We can simply scroll down, ignore all of those words, whoops, scroll down, ignore all of those words, and just work these couple things in, right? Work these couple things in. So let's try and do that now. So we're dealing with just this problem at this point in our lives. So let's fill in what we know. What do you want to fill in for h? 0. What do you want to fill in here? Nothing. Negative 16t squared plus, well, it's plus vt, so what do you want to fill in there? Negative 64? So it's actually a minus 64t. And then we want to have a plus 192 because it was starting above the ground. This is the problem that we have to solve. And the question becomes, the negative 16 is the gravity. So gravity is always going to equal negative 16. It's actually negative 32, but we take half of gravity when we do these problems. And every year I say I'm going to come up with, tell you why that is, and I always forget to find out why. But we take half of gravity to do these problems. So it's negative 16 feet per second, so make sure you're in feet. And there will always be a negative 16 in your equation. Okay? Unless you're doing it in meters per second, or you're doing it on the moon, where gravity's different. Okay? So, great question. Thanks for asking. But it will be built in. Now we just work on this. And it does say how many seconds. So what do you think we're looking for? How many seconds is what we're looking for? So something is equal to question mark. How many seconds? What is equal to question mark? What are we looking for? 0. We're looking for something. Seconds is a value of what? Time. T equals question mark. We want to find t. Find t in this equation. Let's rewrite the equation the more comfortable way. Negative 16t squared minus 64t plus 192 equals 0. Now start thinking for a moment about what you would take out of this equation. What would you take out? Is there a GCF, or do we got to go straight into it? What do you think, Ryan? 8 is the GCF? Does anything higher than 8 go in? I'm not sure, but I would like 16 divide in. Can you take your phones out and do the division, please, by 16? I'm going to take a negative 16 out. And I'm going to ask you guys to tell me what's going to be on the inside here as I take out that negative 16. So notice that when we do this, we're doing reverse distributive. What needs to be there? What needs to be there? Yes? T squared. Okay, great. What needs to be here? Well, it's 16 times something to get 64. 4, so plus 4t. And then here we have this guy, which is going to get positive 192? Yes. Positive or negative 12? Negative 16 times negative 12, right? Negative 16 times negative 12 is 192. Here's where we are. Now here's where I want to state something that sometimes we've glazed over this. Guys, when you have a problem, and you have a math problem that's not very attractive, you want to make it more attractive, right? Is there any way we can make this math problem right here more attractive? Caden? Yeah, now guys, looks aren't everything, okay? We know that. It's all about what's on the inside. But having an attractive problem is not a bad thing, right? Having a good-looking problem, right? One that you feel attracted to? Yes? So when we divide by negative 16 on both sides, we have t squared plus 4t minus 12 is equal to 0. 0 divided by negative 16 is 0, and we have a much more attractive problem here, right? It looks good. And less stressful also, right? Okay, so now we just need to solve that. What do we do next? Yes? I wouldn't add 12 to both sides. That was a comment that was made, but I wouldn't add 12. Yes?
You would, the thing where you got 2 parentheses?
Yeah, the thing where you got 2 parentheses. We call that factoring. T and T. What do you got for me, sir? Shall I identify you? Caden, if you will. 6 and 2 is correct. Now we just got to figure out how we're going to get positive 4 out of that. Ryan?
6 and negative 2.
Positive 6 and negative 2 is correct. Now guys, listen. In my classroom, now if you're watching from home, you might not know this, but in my classroom we just had a long discussion about what the next step is here and why the next step is what it is. So we're going to recap that on this video. We're going to show you what we know. Go ahead.
So, t plus 6 equals 0, t minus 1 equals 0.
So it's possible, maybe, just maybe, t plus 6 is equal to 0, which would give us t equals negative 6 for an answer. Now why is that? Because if 2 things are multiplying to get you 0, what do you know about those things, or one of them? If 2 things multiply to 0, one of them is 0. If you have x something times y something equals 0, that means that maybe x was equal to 0, or y was equal to 0, or both. Right? That's the only way it happens. So now we go here and we say, what do we got to do with that? Jump in here. We're going to keep this video short, yeah? What do we got? Madison? Yeah. Or maybe t minus 2 equals 0, so t equals 2. Now, guys, looking at your answers, we have a red answer, we have a green answer. One is saying that t equals negative 6. Can somebody give me that in like in a sentence, in layman's terms? Like you were saying it to a friend? What does t equals negative 6 mean in the context of the problem? It will take negative 6 seconds. It will take negative 6 seconds. How does that sound to you? How does that sound to you?
Very bad.
Very bad. That does not make a lot of sense to me. It shouldn't make a lot of sense to you. So t equals negative 6 is what's called an extraneous solution. We toss it. Mathematically, it has a reason. There's a reason for that negative 6, and I can show it to you. I won't do it on this video, but I can show it to you. But in the actual problem, t equals negative 6 would be 6 seconds in the past. And we're not going to hit the ground 6 seconds in the past before we jump, right? We're going to hit the ground when? 2 seconds. So whatever happened here is 2 seconds later. The object that's shot down is going to hit the ground 2 seconds. So I'm going to write that here, and I want you to understand that this is our answer, right? 2 seconds, right? That's important. Okay, maybe that doesn't look so great, but that's important to understand that 2 seconds is the amount of time. It took 2 seconds. Now, I want to show you, I said I wasn't going to do this in this video, but I lied. I'm going to show you why that is, okay? So if this is the object, right, here, and it's being thrown downwards like this, yeah? So this is actually really happening, correct? And this is t equals 2. This is 2 seconds. T equals 2. And this is t equals 0, right? What do you think that t equals negative 6 is all about? What do you think that's all about? Anybody have any ideas? Well, what happens is if you were to kind of continue this like this, isn't this the shape of the graph? Right? So this is like a kind of an imaginary solution, but this would be negative 6 seconds before. So if the object was moving along this path, right? If the object was moving along this path, it would have been at the ground negative 6 seconds before. I think I have some concerns with what I just said, so we will kind of let's just actually revisit that for a second, okay? Because typically this is kind of what that means, that extra solution that we throw out, but I actually am wondering to myself right now. So let's just pause this for a moment. So we did a little investigation here in my class, and we had a little discussion, and what we realized was that everything that's dotted is imaginary. It never really happened, right? But everything that's a solid line actually happened. So what I'm trying to show you is that this t equals negative 6, there's a reason for it. Mathematically, there's a reason for it. So if we imagine this ball, or whatever this object is, being thrown down and hitting the ground after 2 seconds, I believe that it would take 4 seconds for that object to go all the way from the top of its trajectory if only gravity was messing with it, right? It would take 2 seconds to pick up the speed to here, and then it would drop for 2 seconds, go faster and faster, and hit the ground. But in a perfect world, if we were able to take the human component out of it and reverse the clock, it would be negative 6 seconds that the object was on the ground. So that should be where we are, I think.